Alright, so the boat is moving towards the dock at 5/2 feet per second. So how do we come up with that? Alright, well here's the picture I drew, here's my boat. This is X is the distance from the boat to the dock. So this is the dock. Person is standing up here. So the dock is constant. The height of the dock is constant. That's not going to change. And Z is the rope that is being pulled. So I know Y is 6, dy dt is 0, Z is 10, dz dt is 2 feet per second. X is going to be 8 when Y is 6 and Z is 10. Again, that's a 6, 8, 10 triangle. Had it not been one of our Pythagorean triples, then we could use the Pythagorean theorem to find it for the other two given values. Dx dt is what we're trying to solve. So again, our relationship though between the three variables is x squared plus y squared is z squared. So when we do the derivative, we get 2x dx dt plus 2y dy dt equals 2z dz dt. You should show this step even though it's going to be the same every time you have a right triangle. I still want to see it. The 2's go away, and so then I can substitute in. X is 8, dx dt is what I want to find, y is 6, dy dt is 0, z is 10, dz dt is 2. Solve for dx dt, and I get dx dt is 5/2 feet per second. Write that in a sentence with the context of the problem. Last one. At a certain instant, each edge of a cube is 5 inches long, and the volume is increasing at a rate of 2 cubic inches per minute. How fast is the surface area of the cube increasing? So again, I want you to try to do this on your own. Think about what variables are being related, what we're trying to find. So pause the video, unpause when you're ready to check your work, or you get stuck. Alright, so we should end up with the surface area is increasing at 8/5 inches squared per minute. Now, how do we come up with that? Okay, well first we know we're starting with a cube. So the volume of a cube is x cubed. We know we're trying to find this rate, or these rates, when x is 5. We know dv dt is 2 inches cubed per minute. We don't know dx dt, and we're trying to find the rate of change of the surface area with respect to t. We know that the surface area equation is 6x squared. So first I have to use the volume equation to solve for dx dt, then use the surface area equation to solve for dsa dt. So the derivative of the volume is dv dt equals 3x squared dx dt. I know dv dt is 2, I know x is 5, so dx dt is 2/75 inches per minute. Now I come over to the surface area equation, take the derivative. The derivative of the surface area is dsa over dt equals 12x dx dt. Now I can plug in x is 5, dx dt is 2/75. I simplify and I get 8/5 inches squared per minute. So then the context again is the surface area is increasing at 8/5 inches squared per minute. So, related rates are just using the chain rule and implicit differentiation with respect to time. They're almost always word problems, so we do need to be able to draw our picture. We need to understand how the rates are related, right? Yeah? It's not just a clever name. Also, we want to make sure that we perform step 3 of the guidelines before we perform step 4. Otherwise, you will get incorrect rates.